You wake up, check the headlines, and there it is. 5 volcanic eruptions and 2 magnitude 6 earthquakes all in the span of one day. Western Sumatra shakes, central Alaska rumbles, and halfway across the planet, volcanoes belch ash and lava into the sky like Earth's having a full-blown meltdown. At first glance, it just seems like another spike in the planet's natural chaos. Earthquakes, volcanic eruptions, nothing new. But when this much activity hits all at once across completely different tectonic zones, it starts to look less like random chance and more like a message from deep within the Earth. Something is stirring.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
Here's what we know. 2 magnitude 6 earthquakes, one under the ocean off western Sumatra and the other jolting through the crust of central Alaska. Both seismic zones with long and violent histories. At the same time, 5 volcanoes, spread across different continents and geodynamic environments, erupt almost in unison. The locations vary. The types of magma vary. But the timing? That's the thread we can't ignore. The Earth is a system. A big, messy, interlinked system of plates, faults, heat, stress, and molten rock. And when that system starts lighting up in several places at once, people start to ask, are these events connected? The short answer, not directly. Not in a domino falls, cause and effect way. But the long answer, the one geologists and seismologists quietly study behind layers of technical data, hints at something more intricate. Something that doesn't follow clean rules. Because Earth's crust doesn't operate like clockwork. It operates like a tangle of rubber bands, all pulling, stretching, resisting until one snaps, and the force shifts. Let's start with the earthquakes. The Sumatra quake wasn't some isolated pop. It occurred in one of the most volatile subduction zones on the planet, where the Indo-Australian plate dives beneath the Eurasian plate. This zone is infamous. It's where the catastrophic 2000 for Indian Ocean tsunami was born, unleashed by a magnitude 9.1 quake. Every tremor in this region isn't just noise, it's a reminder that the megathrust lurking beneath hasn't let go in a while. And it's due. Then there's Alaska, also part of the Pacific Ring of Fire. Another subduction zone, this time, the Pacific Plate diving under the North American Plate. Same mechanism, same tectonic tension, and in both cases, these moderate quakes, strong, but not catastrophic, hint at energy moving, stress shifting, but not yet releasing in full. Now let's talk volcanoes. These weren't all coming from the same type of tectonic setting. Some erupted in subduction zones where crust melts under pressure. Others may have been fueled by mantle plumes, where columns of hot rock punch through the crust from below, like the Hawaiian hotspot. And still others erupted in rift zones, like in East Africa, where the crust is actively tearing itself apart. 3 completely different origins, but they all exploded within hours of each other. Coincidence? Maybe, but there's something unsettling about the timing. When earthquakes happen, they don't just shake the ground, they send shockwaves across the planet. Some of those waves are strong enough to trigger movement in distant faults, or even stir up magmatic systems already on edge. It's called dynamic triggering. And while it doesn't cause volcanoes to erupt outright, it can be the final straw for a magma chamber that's been pressurized for months. On top of that, earthquakes change the stress field of the crust. They redistribute tension. Nearby faults feel the effects, some loosen, some tighten. It's called static Coulomb stress transfer. It's messy. It's unpredictable. But it's real. One quake doesn't just release energy, it reshapes the entire stress map of its surroundings. And when that stress builds silently for years, all it takes is a little nudge. So maybe the Sumatra quake subtly influenced the plate boundary near it. Maybe the Alaska quake shifted stress onto an adjacent fault. Maybe one of those volcanic eruptions, say, Klauia or one of the rift volcanoes, was already close to the edge, and the seismic waves tipped it over. But here's the wild part. None of this means a catastrophe is imminent. This is the part people misunderstand. The Earth always releases energy. Through little quakes. Through eruptions. Through slow slip events, these bizarre, silent shifts in the Earth's crust that don't even cause shaking. It's all part of a gigantic, global balancing act. Energy builds. Energy releases. Over and over. But here's what's missing. Where are the big ones? The magnitude 7 south, 8 south, and 9 south. The true megathrust quakes. The catastrophic energy releases that shake cities and alter coastlines. Because we haven't had many recently. Not as many as we should, statistically speaking. And that's making a lot of scientists nervous. The Earth isn't quiet. It's active. But it might not be releasing enough. These moderate quakes and smaller eruptions could be acting as pressure valves, or they could be signals that pressure is still building.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
This is the paradox of earthquake forecasting. We can see the signs. We can measure the strain, the uplift, the gas emissions. We know which zones are locked. We can model the probabilities. But we can't predict the when. That's what makes this so terrifying and fascinating. Earth doesn't run on a schedule. It runs on thresholds. And when those thresholds are reached, you get rupture. Massive, landscape-altering rupture. A quake that doesn't just redistribute stress, it redefines it. One that sends shockwaves around the globe, physically and scientifically. And the more time passes without one of these big events, the more elastic energy piles up quietly, invisibly, under our feet. This is why researchers focus on slow slip events. They happen deep in subduction zones, where the plates grind past each other without making noise. But these seismic slips do change the game. They can relieve pressure, or, in some cases, load more stress onto the locked part of a fault. That's the problem. Even when the Earth moves quietly, it's still preparing for something louder. And don't forget magma. Volcanoes aren't just about lava, they're pressure systems, closed systems. And when gas builds up inside them, and the pressure exceeds the strength of the surrounding rock, they blow. Sometimes that happens after a slow trickle of lava. Sometimes it happens after a massive quake alters the plumbing. Sometimes it just happens because time ran out. So when we see 5 volcanoes erupt and 2 strong quakes hit within 24 hours, across different settings and hemispheres, we're not saying it's a chain reaction. We're saying it's a pattern, not in a conspiratorial way, in a systems behavior way. Energy is moving, the Earth is active, and something's still missing. It's the quiet before the break. We're in a global game of tectonic Jenga. Blocks are moving, plates are shifting, and we don't know which piece gets pulled next. But we do know that the entire tower is under strain. This is why monitoring matters. Seismometers, GPS stations, satellite imagery, gas sniffers, tilt meters, these are the tools we use to read the planet's mood. They don't predict, but they whisper clues. They catch changes, they raise red flags. And when we put them together across borders, disciplines, and fault lines, we start to see the outline of what might come. Because the truth is, earthquakes and volcanoes don't care about politics, economies, or calendars. They don't care that it's inconvenient. They're driven by physics, by heat, pressure, friction, fluids. And when the system hits its tipping point, it goes. So where are we now? We're watching, listening, modeling, not to predict doom, but to understand the rhythm. Because the Earth does have a rhythm, it's just not one we've fully decoded yet. But this past 24 hours, it's a beat worth paying attention to. Let us know your thoughts. Are these events just coincidence? Is the Earth releasing pressure or winding up for something bigger? Drop a comment below. Like the video if you learned something new. And hit subscribe, because the Earth isn't done shaking things up. And neither are we. And the longer you watch the Earth, the more it becomes clear it doesn't just erupt, it communicates. Through tremors, through pressure changes, through tiny blips in GPS data that show entire mountains rising by centimeters. It whispers before it roars. And the last 24 hours, that wasn't just geological noise. That was the Earth clearing its throat. Because when you look at 5 volcanoes and 2 magnitude 6 quakes within one news cycle, scattered across tectonic boundaries like a crime scene with no clear motive, something deeper is happening. These aren't coincidences, they're signals. And the scariest part, we're still missing the full message. Let's go deeper. When an earthquake hits, it's not just a point on the map. It's a release. A snap in the crust, a surge of energy that's been building for years, even centuries. The Sumatra quake, that was deep and subduction related. The kind of quake that doesn't always bring down buildings, but sends a ripple through the entire tectonic framework. A reminder that a megathrust fault is awake. Alaska, same energy, same locked fault type, different location. But the story doesn't end with shaking ground. Because in those same 24 hours, volcanoes erupted, not just 1, but 5. In different tectonic settings. With different magma chemistries, different styles. Some were effusive, some were explosive, some quiet, some chaotic, but all within hours. Now here's the thing. Most people think of earthquakes and volcanoes as separate. A quake is a jolt, a volcano is a boom. Different beasts, but they're more connected than we admit. They're both release valves. And Earth's crust is like a sealed pressure cooker that never turns off. The mantle below constantly pushes heat and material upward. Tectonic plates grind, pull, and crash into each other. Faults lock, magma collects, gases build, and when that pressure reaches a limit, it has to go somewhere. Sometimes it's a slow release, a quiet slide along a fault, a slow lava flow, a harmless tremor, but other times, it's violent, a full rupture, a chamber collapse, an eruption so fast, it changes the shape of a mountain. That's what makes this moment so unsettling. All of these events, the quakes, the eruptions, they may not be causally linked, but they're definitely part of the same system, the Earth's energy system. And when that system starts lighting up in multiple ways, across multiple continents, that's not just noise, that's data. It means something is shifting. But here's the part no one can explain, not with confidence anyway. Where's the big one? Where's the magnitude 7.8 rupture we should have seen by now in the Pacific Northwest? Or the massive Tokyo area megathrust quake scientists have been quietly modeling for years? Where's the next movement along the North Anatolian Fault, overdue and creeping westward? Because when energy builds in one place and releases in another, it can delay the inevitable, or speed it up. It's like pressing on a balloon in one spot. The air doesn't disappear, it just moves. And eventually, something gives. That's the reality of stress transfer. Static stress transfer, for example, changes the likelihood of nearby faults slipping after a quake. It doesn't guarantee an aftershock, but it increases the odds. And in complex fault networks like Indonesia, California, Turkey, or Japan, that extra stress can propagate in unpredictable directions. Then there's dynamic stress shaking from seismic waves that travel thousands of kilometers and jostle magma chambers, even if only slightly. In just the right conditions, that jolt is enough, not to cause an eruption, but to trigger one that was already teetering. It's not science fiction. It's science with margins of uncertainty. That's the frustrating truth. These processes are real, observable, measurable, and yet still can't be predicted with precision. We know stress is building. We know where the fault lines are. We know which volcanoes have swelling chambers and sulfur emissions rising like steam from a kettle. But what we don't know is when those systems will fail, because Earth doesn't follow our schedules. And that brings us back to what's missing. Not just a megathrust quake, but a pattern we can rely on. The last 24 hours delivered chaos. But not the kind that lets you plan. No, this was the kind that hints. A tremor here, a lava fountain there. Enough to catch your attention, not enough to tell you what's next. And that's where things get really serious. Because the absence of a major quake in a high-risk zone doesn't mean safety. It means potential. And the longer the silence, the louder the eventual rupture tends to be. Think about Chile, about Japan, about Sumatra in 2004. In each case, there were periods of eerie quiet before everything gave way. And in hindsight, the signs were always there, just scattered, subtle, or misunderstood. And today, we have more tools than ever. GPS networks that can detect millimeters of movement, satellites that track magma bulges, AI systems parsing millions of seismic records. And yet, we're still surprised, still behind. Why? And here's what's real. Preparedness doesn't start with panic. It starts with understanding. Understanding that volcanoes and earthquakes don't need to be linked to still tell a bigger story. Understanding that silence isn't safety. Understanding that science isn't perfect, but it's all we've got and it's getting better. So the next time you see a cluster of eruptions and earthquakes lighting up the globe, don't scroll past it. Pause. Ask, what's the Earth trying to do right now? Where is the energy going? And are we listening? Because buried under every eruption, behind every seismic jolt, is a message. One we've only begun to translate. And when the big one does come, whether it's tomorrow or 10 years from now, it won't be without warning. The warnings are already here. 5 eruptions, 2 quakes, 1 missing piece. Will we see it before it moves? So here we are, still waiting, still watching. Because in the aftermath of 5 volcanic eruptions and 2 strong earthquakes within just 24 hours, the question isn't what happened. It's what hasn't yet. That's the tension you can feel in the silence that follows seismic noise. When magma settles, when aftershocks fade, when ash stops falling, and the headlines move on. But beneath our feet, nothing's over. The planet is never still. Let's be honest, if 5 volcanoes erupt and 2 magnitude 6 quakes hit in one day, and it doesn't even crack the front page in most places, that tells you something. Not about the events, but about how normalized we've become to the instability of the ground we stand on. Maybe it's a coping mechanism. Because if we really stopped to think about it, that at any given moment, somewhere beneath us, stress is accumulating silently. It might be too much to process, But this isn't about fear. It's about clarity. These events are a reminder that the Earth isn't chaotic. It's complex. And complexity doesn't mean randomness, it means layers. Processes stacked on processes. Systems feeding into other systems, from the inner core to the stratosphere. And let's talk about those ripples for a second. Because every single time a large quake hits, it sends out seismic waves like throwing a rock into a pond, but on a planetary scale. Those waves don't just shake the surface. They interact with other systems. They pass through crustal weaknesses. They hit magma reservoirs. They can push a fault line from almost ready to slipping now. It's like tapping a domino that's already tilting. No force needed, just timing. And this is why volcanologists, seismologists, and geophysicists are all paying attention to the timing. Because that's the part that's not random. When multiple systems activate at once, something deeper is at play. Maybe it's the way stress is being redistributed globally. Maybe it's a deeper mantle pulse. Maybe we're watching Earth shift gears in ways we don't yet fully understand. But here's what we can understand. The absence of a megaquake lately isn't comforting. It's suspicious. Think of it like this: pressure is still pressure, whether it releases in small bursts or one massive rupture. And if we're only seeing moderate quakes while locked faults remain stubbornly silent, that doesn't mean we're in the clear. It means we're holding our breath. That's what the data keeps pointing to. Accumulated energy. Tightly locked zones. Fault lines that haven't slipped in a century or more. Add that to an uptick in volcanic unrest, and you've got a planet adjusting somewhere even if we haven't seen the final domino fall yet. And maybe you're thinking, okay, but what do we do with all of this? That's the right question. Because this isn't about predicting doom. It's about respecting the system. About taking seriously what the Earth is showing us in real time. The tremors, the gas emissions, the surface deformation, it's all communication. And our job is to listen. Maybe that means updating emergency plans in quake-prone areas. Maybe it means funding more dense seismic networks. Maybe it's as simple as not dismissing volcanic alerts because nothing happened last time. Because next time might not be nothing. This is how Earth works. It builds, it shifts, it releases. Sometimes in small moments spread across the globe. Sometimes in one cataclysmic release that redefines geography and resets everything. And when we look back at this 24-hour window, this strange convergence of geological outbursts, we may realize this was the moment the gears started turning. The moment the Earth warned us, not with a scream, but with a pattern. And the question we'll have to answer is, were we paying attention? If this resonated with you, share it. Drop a comment with your thoughts, especially if you're in a region sitting near one of those locked faults. Like the video if you're starting to see the signs. And subscribe, because as long as the ground keeps moving, you better believe we're going to keep following it. Thanks so much for watching. If you made it all the way to the end, you're officially part of the small percentage of people who don't just click away, and that means a lot. Before you go, I'd love to hear from you. Drop a comment below and tell me your thoughts, your ideas, or even what you'd like to see next. I read every single one of them, and your feedback genuinely shapes the direction of this channel. If you enjoyed the video, tap that like button. It tells YouTube this content is worth sharing. And if you haven't already, hit subscribe and turn on notifications so you don't miss the next upload. We've got more exciting videos coming, and trust me, you'll want to be here for them. This channel is just getting started, and your support helps it grow faster than you realize. Thank you again for spending a part of your day here with me. Stay curious, stay motivated, and as always, take care of yourself. Until next time, I'll see you in the next video.